So in this video, we'll actually prove two things. First, we'll prove sum of the three angles of any triangle is uh, equal to 180. So let's say I'm given this picture, triangle ABC. If you add three angles, small a, small b, small c, the sum is going to be 180. How do we really prove it? Now, in order to prove it, we'll have to draw a line through point C that's parallel to AB. Then we can say angle A and angle X are congruent. Let's write it down here. Let's write it down. Proof. And what's my proof? Well, let's see. Angle A, angle A is equal to angle X. And the reason is they are corresponding angles. Corresponding angles. Corresponding angles are congruent if those lines are parallel. If lines, this dotted line and line AB are parallel, A and X are corresponding and they're congruent. I can say something very similar with angle B and angle Y. They're also congruent because AB is parallel to this dotted line. And now I'm almost done. Since angle X, angle C, angle Y, they together they are on this dotted line, they better add up to 180. So I'm going to write it down. And I'm just going to write, I'm not going to write, well, let's write angle. It doesn't hurt. I don't have an angle symbol here. Angle X plus angle C plus angle Y is equal to 180 because they are on a straight line. You can't say a linear pair, but you can say they form a straight line. They are on a straight line. They are on a straight line. Now, instead of x, because x is equal to a, instead of y, I can replace, instead of x, I can write a. Instead of y, I can write b. And I am done. I just proved that the three angles of any triangle, picture we had really, this picture is of any triangle. And in a fairly similar way, I can prove that even if your triangle was not acute, if it was obtuse, you could use a very similar argument to prove that angle A plus angle B plus angle C is 180. And this is 180 degrees. All right, guys, so we're going to use this result to prove our next result. Okay, so here what I have any polygon. Now I have written the proof here so that it's a little easier for me to explain. I have any polygon. I have a triangle here. I have a quadrilateral here. I have a pentagon here. I have a hexagon here. Now I am trying to prove that some of the interior angles of any polygon with n sides is going to be n minus 2 times 180 degrees. This is what I'm trying to prove. Sum of the interior angles of any polygon with n sides is n minus 2 times 180 degrees. How do we really do that? It's actually a middle school topic, so it's not that difficult, but it's something we have to use to solve some of the problems. Now, if you have a triangle, we have just established that these three angles will add up to 180. If you have a quadrilateral, you can cut it up into two triangles, and the three angles of the two triangles are really four angles of the quadrilateral, and they better add up to 2 times 180 degrees. If you have a pentagon, you can cut it up into three triangles, and the three angles of these three triangles together form the five angles of the pentagon. So the answer should be 3 times 180. If you have a hexagon, you could cut it up into four triangles. I know I cut it up a little differently here, but you can cut it up into four triangles as follows as well. You can say, I'm going to cut it up like this. You're going to cut it up like this. Two, one more. Three. You have three triangles. Sorry, you have four triangles. So the four triangles, all the angles of the four triangles together represent the six angles of the hexagon. So the six angles of the hexagon better add up to 4 times 180. Now take a look at these green numbers. If you have three sides, it's 1 times 180. If you have four sides, it's 2 times 180. If you have five sides, it's 3 times 180. If it's six, it's 4. So what pattern do you see? It's always 2 less. So if you have a polygon with n sides, the total number of the sum of the interior angles of the n angles should be n minus 2 times 180 degrees. Oh, that's nice. I can do degrees here. Great. And just write degree as follows. Again, this is sum. If you add all the angles of an n-sided polygon, that's the sum you will get. Now, if it's an let me get rid of this. Let me give you one example. So let's say I have a 100-sided polygon. Let's make it 100-sided polygon. What will be the sum of those 100 angles? Well, we're going to say that's going to be 100 minus 2 times 180 degrees. Okay? And I'm going to write sum. It's not just one angle, it's the sum. Now, 100 minus 2 is 98. So I'm going to go ahead and multiply 98 by 180. I'm going to multiply 98 by 180. I'm using a calculator. And that turns out to be 70,640. That turns out to be 17,640 degrees. I hope that helps. So in this lesson, we learned how to find the sum of the angles of any polygon. These are interior angles. Interior angles are angles that are completely inside the polygon. Thank you.